Now this problem is related to applying energy conservation. So read the problem. So question says, what is the maximum compression of a spring? So we have to find maximum compression in the spring. Now what will happen? This block is initially here, mass is m, velocity is v, and we have this spring. Now this block is going with velocity v, so a time will come when this block will start pushing this spring. So now this spring gets pushed by this block and velocity will decrease, because at any intermediate situation, let us say block is here, now a spring is also applying a force onto the block, so velocity of block will decrease because there is a deceleration. So velocity of block will decrease, and a time come then velocity of block becomes 0. So let us say at this point velocity of block is 0. So now this has 0 velocity. So if you see, initial spring is here, now a spring is here, so spring is basically compressed by some distance, and this compression is maximum because block cannot compress the spring anymore because its velocity is 0. Let us call this compression is x maximum. So we can say when we have maximum compression in a spring, velocity will be 0. So at the time of maximum compression, velocity of block will be 0. So we can apply energy conservation for situation number 1, and let us call this situation number 2. So apply energy conservation. In situation number 1, that is initially, we have only energy, that is kinetic energy of this block. A spring is its natural length, so it does not have any potential energy. So initial energy we have, that is half m v square. Finally block has 0 kinetic energy, but the spring has potential energy, half k x max whole square. So from here we can write k x max whole square is equals to mv square. So x max, that is m by k, v square under root. So v under root m by k. So this is the maximum compression possible in the spring. Now next part of the question says, will the velocity of block be same as v when it comes back to the original position? Now what will happen? Now a spring is still applying a force on this block, velocity of block is 0. So now block will start accelerating in this direction. So block will have a velocity in this direction, and a time will come when this spring gains its natural length. At this time block is here. Now this block will move with velocity v again. This can be proved. Now what is the total energy this time? Total energy, let us say this is v dash, and we can prove v dash is basically equals to v. So total energy this time is half m v dash square. Now in the whole process there is no loss of energy, because there is no loss of energy in a spring, there is no loss of energy in the surface, so no loss of energy in the whole process. So we can apply energy conservation. Let us call this situation 3 between 1 and 3, because one situation this is going with velocity v, and now this is 3 situation, it is coming in this direction with velocity v dash. So if we apply energy conservation in situation 1 and 3, we can write energy in situation 3 is same as energy in situation 1, that is half mv square. In both situations potential energy stored in the spring is 0. So from here we can write v dash is equals to v. So now the block is going in this direction with again same velocity, but direction will be opposite. So block is going with same speed, but with opposite direction. So velocity is not same, speed is same. So velocity at two stand is not same, because velocity is a vector quantity, but the speed is same.